Many years ago, I developed my first After Effects plugin. It was a very simple letterbox generator. Now, despite how simple it looks, it was a month of torture to create, trying to understand the most ridiculous error messages and relaunching After Effects 1,000 times a day. So what if I told you there was another way to create plugins? We have just released the laForge plugin, and this is a plugin building plugin. It may sound strange, but look, we have a code editor inside of After Effects. So today I will be showing you how you can use the laForge plugin to create your own effects inside of After Effects. This is part 1 of a series of videos, so we're starting with a very simple long shadow effect. And in future videos, we will cover how to create 3D effects and volumetric effects. You can download a free trial of the plugin on the ProductionCrate website. The free trial does have a watermark, but it allows you to access the code editor. I've linked below an installation video if you need any help. So now let's actually try to make a plugin inside of Adobe After Effects. I've imported my footage and pre-composed it. So to add a laForge effect, go to the effect menu, go down to ProductionCrate and select laForge. Now a few buttons appear, but we will be clicking on the Start Panel button. Once that pops up, make sure that you enable the Advanced mode with this slider box here. Initially, you will be presented with a bunch of different presets that are included inside the plugin. So we have color warps, aurora generators, glows, god rays, fractals, ocean generators, and so many other useful tools that you can utilize in your projects. You can apply this to your footage simply by selecting a preset and clicking the Apply Selected Preset button. And if you move the window and go back to your layer, you can see this incredible effect has been added. And best of all, it is a 3D effect that you can actually explore with your After Effects camera. Feel free to explore the other presets that are included, but now I will move on to the editor window. So clicking that takes you to a preset settings page. This is actually where you can customize the name, the author, the version, and the description of your own plugins. You can also add tags to make it easier to find the plugin. Now there is a sub window named the code editor. This is where you can create and program your own effects. And it really is incredible how this is built inside of After Effects so that when you click the apply button, your plugin will compile and be immediately accessible inside of Adobe After Effects. I just want to quickly show you the parameter settings page. This is actually where you can create your own sliders and parameters. So with the cubic fractal, for example, we've created warp sliders that distorts the fractal, and we've also created color sliders, which any user can utilize without actually needing to program the plugin that you've created. There is also a textures window that allows you to reference other layers inside your project. So this can be used for displacement maps or matte generators. Anything that needs to reference another layer can utilize this page to select up to 5 different layers, which includes the source layer. So I'm back in the code editor. For context, this uses GLSL, which is a shader programming language. This is utilized a lot in real-time game engines such as Unity or Unreal Engine. But here we are using it to create an After Effects plugin. If you've never used GLSL before, I highly recommend looking up some tutorials, but if you've had some experience already, I will say that this language is a very forgiving language. The syntax is very easy to pick up, and all of the built-in functions are incredibly useful. So now let's create a very simple tinting plugin. So this is the template code that is provided at the beginning. It begins with a main render function. So to clarify, anything that you write here will be executed per pixel. This is the first thing that will be executed in your laForge effect. It provides a coordinate for the current pixel, and it requests the out color, which is the final pixel color that you will display on the screen. The next line is very simple. It simply says the pixel that we want to push out should be the same color as the current pixel. So it basically copies the current layer. And it does this by using a texture LOD function, which samples the texture 0 texture, which if we check on the texture window, you can actually see this is the variable used for the source layer. And after that, it requests the coordinate we want to sample. We want to use the Forge UV variable for this. And after that is a random setting which allows you to control the mipmap strength. A mipmap is an easy way to simulate a blurred effect by utilizing progressively downscaled versions of the texture. So we basically know now that this portion of code here represents the current pixel. And so to tint this with a color, we want to multiply it by a variable that we can name Tint Color. So if you click on refresh, this will compile the code. And you can see that we actually have an error message in the console. And it's quite useful because it tells you which line the error occurs on. And so in this case, it mentions that the tint color is an undeclared identifier. This is because the variable here doesn't have an associated value. So to give it a value, we want to create a color parameter. So if we go to the parameter settings and go to the color tab, we can enable a color parameter by clicking on the visible checkbox. I will be naming it Tint Color. And since I've written it slightly different here compared to how I have in the code editor, I want to disable the function name is the same as GUI name here. And this reveals another column named code name. So all we have to do here is copy the tint color from the code editor and paste it into this code name variable here. Now, when we go to the code editor and click refresh, you can see another error has appeared. This looks confusing, but it basically says that the variable here is a vec3 variable. A vec3 variable is a way to contain 3 different values in a single variable. In this case, we usually use it to contain the red channel, the green channel, and the blue channel in a pixel's color. A vec4 is basically identical, except we also have the alpha channel. The problem we're having at the moment is we're trying to multiply a vec4 variable by a vec3 variable. So it gets kind of messy. So to get around this, I will be adding vec4 and an open bracket before the tint color. And at the end of tint color, we will be doing comma 1.0. Now, if I close the bracket, we've converted it into a vec4 variable by combining the RGB channels of the tint color by an artificial alpha channel, which we are just giving the value of 1. So now, if you click on refresh, compilation has been successful. So now let's apply it inside of After Effects. Make sure you have your footage as well as your laForge effect selected. And then on the bottom right, we will be clicking Apply Preset. Now, if I move the window down, you can actually see that our color parameter has been created. Now let's try changing the color. And you can see that our tint effect is actually working. And look how quickly it's running as well. This is why we designed this to run on the GPU. Now, the incredible thing is that this plugin is now embedded inside your project. This means that if you send this project to anybody else, as long as they have the laForge plugin, the effect that you have created will work in their project without the need to install any files to their system. It's incredible. Now, just to tidy it up, I will go to the parameter settings and I will rename the group name to just colors. Likewise, I will go to the preset settings and name it Crates Tint. You can then name yourself in the author tab, as well as give it a description. So now if you look up here on the top left, when I click on apply preset, you can see that the group name has updated to colors, which is nice and clean, and the preset name is now visible. Another useful thing is that if you go to the code editor and click on this play button here, you can see that we can actually preview our effects while making them. Now, I actually want this preset to be included in my preset list, but for that to happen, I need a thumbnail. In the code editor, we actually have a frame to thumb button. Now, currently, this isn't too helpful because we can't actually see the tint in the preview. So what I will do is go to the parameter settings and we can set a default value for the color. I'll set it to a red. And when I click the play button again, you can see now it's updated inside the preview instantly. So now we can actually use this in our preset thumbnail. To export a preset, click on Save Preset As, and I will name it Crates Tint. Click on OK, and you can see at the bottom we've got a new preset. So to update the thumbnail, go to the editor and click on Frame to Thumb. Now you have to reopen the laForge panel, and when you scroll down, you can see your preset has now been added. Let's move on to a new plugin. We will be creating a long shadow generator. You see these a lot in motion graphics and very stylish commercials, but for some reason After Effects doesn't have this built in. So here I have prepared a foreground. This has to have a transparent background, because anything that is opaque will be casting a shadow. So let's begin by adding a laForge effect and open the panel. So to get started, let's clarify how we will calculate whether the current pixel is inside the shadow. This circle here can represent a shape, and this little cross here can represent the current pixel. Remember that this effect will process every single pixel independently, so the algorithm that we create has to be able to work regardless of where the pixel is. Let's assume that the source of light is up here, and it's shining a light down this way. So we ourselves know that the shadow would look something like this, but this pixel here doesn't know that. So the way that we figure out whether we are inside a shadow is we start taking multiple steps towards the source of light. And on each of these steps, we check the opacity of the pixel at that location. And if one of those pixels happens to be opaque, then we can declare that it is casting a shadow. And in that situation, we set the current pixel to a black color. Likewise, if there is a pixel being sampled outside of the shadow, and we do this step-by-step process, you can see that none of these sampled pixels will be detecting any opacity, and so this pixel won't be colored as if it has a shadow. So for this to work, we need a few things. First of all, we need the direction of the light. We also need the position of the current pixel, as well as the size of each step in this iterative process. And finally, we need a variable that can store the amount of shadows that have been detected. The direction can be represented with two values, each of these indicating the rate of change in the X and Y axis, because both of those combined can create a vector. So I will create a vec2 variable named direction, and for testing purposes I will give this a value of 0.5, 0.5, just like that. The position can be represented by another vec2 coordinate, and here we will simply take the value from Forge UV. Remember to put a semicolon at the end of every line. The size variable is determined by the pixel size, and since the pixel size is relative to the resolution of the image, the size of the pixel will actually be different in both the X and Y axis. So I will use another vec2 variable named pixel size, and this is calculated by dividing 1 by the resolution. The shadow variable can be represented with a color, and this is done by using a vec4 variable. And as a built-in value, I will give it a black color, which is built by doing 3 zeros, and in the beginning there are no shadows, so the alpha value of the shadow at the beginning is 0. And once again, semicolon. Let's tidy that up. Now, for the sake of simplicity, I want to separate the output color from the input color, so I will copy that line and simply create a new vec4 variable named input color. So let's begin calculating the shadow of the effect. We will be using a for loop to do the multiple steps to calculate the shadow. So to do that, I will begin by doing a for open bracket, and then we have to create a new variable here. I will simply do int x, and I will give it a value of 0. The next part of the for loop is to say how many steps we want to take in this shadow calculation. So in our case, 100 pixels should be enough. And finally, we just want to increment the x value every iteration. Let's do a curly open bracket and press enter. So anything between these two brackets here will be processed 100 times. Now, when you are dealing with integer values, you want to make sure you're not using a decimal point. So now we want to use the current position and increment its value, which can be done with a plus and equals sign. And the value that we are adding to it is the direction multiplied by the pixel size. And this represents a single step. Now what we can do is we can get the shadow and increment its value the same way. And the amount that we are incrementing it by will be the opacity of the current pixel. So I am using the texture sampling function, but instead of the Forge UV coordinate, we want to use the current position. Likewise, we only want to use the alpha channel. And since we are only returning a single floating point value in this operation, we have to make sure that we are only affecting a single value in the shadow variable. So just by adding a .a, you can only manipulate that part of the variable. So we've written a lot, but how do we actually know it's working? What we can do is set the output color to the shadow variable. This is so we can test that the shadow is being generated. So if I make sure my layer is selected and then click apply, we can go to After Effects to see that we are actually getting a shadow being built. But this is just the shadow. To bring back the foreground, we will go back to the code editor. So down here, we don't want to show just the shadow. Instead, we will be mixing the input color with the shadow, and the amount is determined by the inverse of the input color alpha channel. So now let's click on apply again and see that our long shadow is being generated below the foreground. And did you see how quickly that was and how little code that was actually needed to create it? So I want to be able to control the length of the shadow. So to do this, I will go to the parameter settings and then the slider tab, and I will create a new variable called length. Similar to the previous plugin, I want to give it a different name in the code. Here I will just say length. Make sure you set the visibility to on, and if we use the middle mouse cursor to bring ourselves to the right side, then you can see a few more settings here. So for example, we can set the default value, as well as the minimum and maximum values of the slider. So in my case, I want to set the default value to 100 and the maximum value to 500. Actually, I think I will call it the shadow length, because length is actually a function built into laForge. So now I can copy the shadow length and take it to the code editor. And here I can actually replace 100, which is the number of steps taken in the shadow generation process, and set the limit to the shadow length. Now if I refresh the code, you can actually see that it's giving an error. And that's because the X value in this for loop is being compared to a float value. So all I will do is convert the shadow length to an int value by using the int function. Now if I refresh it, compilation is successful. Let's test that this is working. I will go to the apply button again, and if I go back to After Effects, we can see a new slider has been created. And by dragging this around, you can see we're manipulating the size and length of the shadow. Let's add a color control quickly. I will go to the parameter settings, go to the color tab, and I will add a shadow color variable. Likewise, I can give the code name something similar. I will set the visibility to true, and then give the default value a color of black. I'm now going to copy the shadow color, take it to the code editor, and in our shadow color declaration, we can take the first 3 values and simply replace it by the shadow color. I will now apply this to the project again, and if I move that down and change the color, you can see we're customizing the color now. So I can set that to like a blue or a black or a white, and then it disappears, or a light gray. Now we actually want to control the direction of the shadow. So to do this, I will be creating a rotation parameter. First enable it, give it a name such as the direction, and the code name can be shadow direction, and I will give the default value a random value just so that it has an offset instead of being directly vertical. So now I will copy the shadow direction, and in the code editor we can find the direction variable. So the direction variable is made from an X and Y variable to create a vector, but the shadow direction parameter is a single value. And so we have to figure out how to map a single value into 2 distinct different values. There is a weird mathematical way to do this, and it utilizes the sine and cos functions from trigonometry. So to do it, we will calculate the x value by doing a sine function and giving it the negative shadow direction. After that, we actually have to convert the degrees value of the rotation parameter to radians. And so to do that, we divide it by 57.2958. Now for the y coordinate, we do something similar, but instead we use the cos function with the shadow direction, and once again we have to divide this by 57.2958. Now let's check to see that this is working by clicking the Apply Preset button. And when we look back at our project, we can see the direction parameter has been added, and when we begin to rotate it, the shadow rotates with it. So basically you've built an entire plugin within 20 lines of code. That's incredible. If you need any further help with the development of your own plugins, you can check out the documentation panel inside laForge. We would love you to join our Discord where you can collaborate with other developers as well as ask us any questions. We would love to help you create your own effects. Remember that you can download a free trial of the laForge plugin, which will allow you to use the code editor and start experimenting. Thank you so much for watching, and remember to make it awesome.